Okay, so let's move on to the hand-coded logistic regression model. First thing we want to do is convert the sex category from male-female to binary. So all that we'll do for that is create an integer type on these, the tail part here is as type int. But what we're going to do, this will create a Boolean series of true, false. And then we're just going to convert those. So true, when we convert to int, true will be 1 and false will be 0. And then our train test split. So we want some training data and some test data. For our training data, these are the things that we're going to keep. We're going to keep p-class, sex, age, the sibling, the p-arch, and the fair. And we're going to use the pandas sample method to get 75% of our data. And we're going to use this sort of negation here to get all the values that are not in the trained index. And of course, we want the same columns. For the y values, what we're going to do is one-hot encode these. It seems strange because it's binary. It's just going to work for this particular model. So each row in our training and test y values will be length 2. So each row will have 2 entries where the first represents whether or not it's a 0 and the second represents whether or not it's a 1. Again, seems odd, but we're going to do this for sake of ease for this particular model. Let's go ahead and run this and move on to the model itself. So we already have TensorFlow, so we don't actually need that line, but we have it anyway. Now, the data format, we're going to create this so that it has the shape, number of instances, number of features for each of these, number of instances, and number of classes. So that's for the y and the x data. So the number of features, we already know that that's xtr.shape, and that's the first one. And then we have number of classes, we're just going to set that as a 2. Here we're just going to create the placeholders, the variables for x and y, because for this model we're going to use a feed dictionary. So these placeholders, we're going to set those types as float. And the none here, all of that indicates is that the shape, the number of observations we pass in, should be flexible. And then, of course, number of features and number of classes represent the other portion of the shape. Here we're going to create the weights as variables. You're already familiar with this. Instead of get variable, we're just going to use the plain old variable class just for the sake of ease. And we're going to set those, we're going to initialize that as a set of zeros. So this way we don't have to run an initializer, we're just going to fill that with zeros initially. And then defining our logistic regression model, here we're just going to wrap the matrix multiplication of these inside of a softmax. The reason for the softmax in this case is because, as discussed before, when you have 2 outputs, you end up with a simple logistic function. Then you would end up with not probabilities. In other words, it wouldn't sum to 1. So the softmax will allow us to sum to 1. So it'll give us the same effect. And then defining our loss function. We're going to use this particular function right here, which runs the reduce mean. So basically we're just taking the mean of softmax cross entropy with logits. So that is a function that's provided to us by TensorFlow itself. Now the logits are the predicted values, and then the labels are the true values. So that's our loss function for this. It's the softmax cross entropy with logits. And as usual, we want to define our optimizer. So here it's going to be the Atom optimizer, and we're going to manually set its learning rate to 0.01, and we're going to minimize on our custom loss function. And create the session. We always need that. All right, so for variables, we're going to initialize all variables. We didn't define any initializers because we just want to start these weights out at 0. If we wanted to define custom initializers, then we wanted the getVariable method. So that initializes our variables, and we're going to set the number of epochs to 10. That's how many times we're going to loop over our data. And so here we're going to loop for I in range num epochs. Then we're going to use the session object, and we're going to run our optimizer and we're going to pass in our feed dictionary for the training values for x and y. Our accuracy function is just going to be this simple function right here, which is going to give us the mean value, its basic accuracy. And so what we have, of course, we want to cast to float, but the inside portion is what we care about inside of reduced mean. So for every single output, we're going to compare the argmax of our prediction. So we're going to get whether it's a 0 or a 1. So if the argmax is 0, then that means that the probability was higher on, remember we have 2 entries, so that means that the probability was higher on the first entry, the 0th entry, versus we would end up with a 1 if argmax were on the index 1, the second entry. And similarly for our true values. Okay, so doing the mean over that just gives us our accuracy. I should mention the equal tells us whether or not these were the same. So tf.equal compares these two things. So it tells us whether this value, whether it would be a 0 or a 1, and is equal to this value, a 0 or a 1. Accuracy value, this is just where we're extracting that actual numeric value using the session. So that extracts it from the graph for us. And so once we run that, then we can test this out and get our accuracy value, and that'll essentially run everything for us, and we have an accuracy of 60%. So not bad, just 10 epochs, pretty simple model, not even all of our data. Okay, so let's go ahead and take a look at our more complex version. This is logistic regression with batching. We're going to use some of the higher level APIs, and this is going to kind of pull together some of the work that we've already done. So we're going to take a look at using estimators along with the batching method that we created in our last video. So here, let's go ahead and read in our data once more, take a look at the head of that data, and we can see everything that we have in our values. Let's just go ahead and take a look at the unique values in these. For some, we don't actually need the specific uniques. Like for cabin, I'm curious about the number of them, although, again, I think we're not going to use cabin. And here we also see that one of our unique values is a null value, so we'll account for that in a moment. Let's go ahead and take a look at our input function. This is going to look really familiar to you, and we have some of these things you may have already seen before. We have the repeat and also setting our batch size. All right, going back up, you also have seen this in the previous video, but we're defining it outside of our input function. These are the default values that you've seen in the tf.decodeCSV. So this time we're setting those outside of the function, and we can kind of get a better idea or a better feel for what these are at this point. We need to match up each of these with the data itself, so let me go ahead and remove those. So looking at our data, we see the order of everything that we have here. This is what's going to be read in. And so for the first one, we definitely want it to be numeric. Same with p-class. So we have numeric on these, and we kind of already decided what we wanted to fill the null values with earlier, so we're just reproducing that here. And then for our sex, we're going to use this short for unknown. And also we want to make sure that if it's a float, like if we have an age, that we have a float in this column. So that's what the decimal is for right there. And then we have 0 for both of these columns, and then a -1 with a float for fair. And of course the last two, unknown. So anytime it encounters a null value for each of these columns, that's what it'll fill with. And then the columns, we're going to actually get the column names, so we're just going to send those to a list. Otherwise, mostly this is the same as before. I passed in the number, or I created the number of epochs argument this time for this particular input function. Otherwise, almost everything is the same. You could feel free to take a look a minute. Oh, we also have a shuffle option. So if you want to shuffle, here we're setting a buffer size, and that's in bytes. So here I've just created, kilobytes. Okay, so 100 kilobytes would be our buffer size if we ended up shuffling. And again, pretty much everything is the same here. So let's go ahead and just create that. Now we're going to take a look at handling of categorical functions. So we could do this outside of TensorFlow, but we actually have the option to do it inside. And for that, we want to use this feature column. So we have, it's really handy actually for doing this for all of our columns. We're going to pass them in using this particular API as opposed to using feed dictionaries. Okay, so let's take a look at sex and embarked. Those are the ones that we're going to keep as far as the categorical features. So for those, we have categorical column with vocabulary list for the sex feature. And that one is, again, this is tacked onto the end of the tf.feature column. What this is going to do for each of these is it creates a feature column with a name and everything that we can pass into our model. Again, it's a lot handier than just using the feed dictionary because then we can handle other pre-processing functions. So here, what this is going to do is use this list. This is our vocabulary list that we can, these are all the values that can be found inside of the attribute for sex. So we have female, male, and then unknown. What this will do is it'll actually create a one-hot encoding for us. So this is a really handy way to pre-process categorical features into one-hot encoding. Super easy. We're going to do the same thing for embarked, and we're going to pass in these values for our vocabulary list. Okay, so let's just return that, and we're going to take a look at some of our continuous or numeric features. For age, let's see, how did I end up with that here? So for age, we want tf.featureColumn once again, but this time we're just going to declare it as a numeric column. And here, again, I should actually have mentioned this with sex and embarked. The very first argument to all of these is whatever the name will be when it reads in from our input function. So we actually have the names that get passed in for the features. So that would just be the name in the column. Okay, so that's all we pass for the numeric column is just the name, and all it's going to do is create a data column for us. And then we're going to use the sib, parch, and fair values. So for each of these, again, we just have numeric columns. This commented line, I just wanted to mention that you can also create buckets. It's really easy to pre-process data into buckets. So if we wanted to, we could actually create, or bins is another way to put that. We can create this using, let me go ahead and uncomment. So age buckets, you do have to pass in a feature column into age buckets. You can't pass the feature name itself. So we would have passed in age and set the boundaries. So here would be the boundaries. Of course, we'd actually want these to be float. So these would be the boundaries, and these are upper level non-inclusive boundaries. So for example, the first age bracket would be 0 to 4, and then we would have 5 to 9, 10 to 17, and on up. So it's a really easy way to bin those and to create features as buckets for numeric values. And the rest of those look pretty normal, so let's go ahead and return that. Okay, so we're going to define our model, and here's where we start to actually create the process for passing in our data. We're going to create a list of all of these feature columns that were created. So this list has the variables age, sib, parch, fair, sex, and embarked. So those are all of the feature columns that we created that we're interested in. And model directory, if you end up passing this other than none into our model, that's going to save a bunch of info about your model as you run this. And then we're going to define the model itself. And this is where we use the TensorFlow Estimator API. And we're going to use this linear classifier, which what it's going to do for us is actually use a logistic regression model. Now the feature columns, that's one of the arguments. So that's where we pass in the feature columns we've created a list for. We're going to define our optimizer as the Atom optimizer. So it's the same one that we used for our hand-coded model before. And of course, you get a bunch of outputs, and you can mostly ignore those. Take a look if you want, but they're not important for this tutorial. And let's go ahead and train our model. So we're going to do model.train. Because it's an estimator, it creates this train function for us, and it's actually going to loop over our data in batches, which we have defined for our input function. So this is the input function we defined earlier, input fn. So for the actual input function argument, you have to, for our custom function, we're going to use this lambda operator and pass in our input function with any necessary arguments. Now we already defined the batch size to be 16, and I think the number of epochs we defined to be 10. So we're just going with the defaults. And of course, the columns. So those are our column names. All right, so let's go ahead and train our model. Okay, so now that that's done, let's pull results out. We're going to use the model.evaluate. And once again, we're going to use the lambda with our input function. And if we wanted to, we could actually pass in a different data set right here. This is just the location of our file, our data file. So this could easily be a training data set that we would have stored. And we just use the same columns. And in this case, because we're just evaluating, we're going to set n epochs to 1. So let's get results. And you can ignore those warnings, no big deal. And let's print the results. So in this case, remember, this isn't training data though, this isn't test data, this is our training data. So we have roughly 79% accuracy, and we get some other metrics here like area under the curve, AUC for precision recall. Overall, really nice, it gives us a lot of metrics. All right, so that's it, and we'll see you next time.